is a very short instruction video for the linear expansion of like a solid material. So in today's experiment, what we're trying to find is the thermal coefficient of a given material or a given metal. So in this experiment, it's going to be very easy. I don't think we will really need any kind of simulation or something like that. So the way it proceeds is like if you take like a metallic rod object, like something as you can see here, and then if you increase its temperature or if you just like heat to go in it, so what will happen is like this object will expand, and that expansion, as you can see from this drawing, is equivalent to delta L. But mathematically you can find that delta L, or the amount of expansion, using an equation, and that equation is equivalent to this. Okay, so the expansion of a certain object, or linear object, mostly like a rod or a wire kind of thing, that has a very small diameter, then it can be calculated using delta L, because it's given that we are assuming like the linear, like whenever you are warming up a wire or when you increase its temperature, it expands just linearly. That means it only expands in one direction. It may expand like in all directions, but the thing is like it expands more in the lengthwise direction. So that delta L can be calculated as delta temperature. That means by how much did the temperature of the metal increased, its original length, L0 is its original length, and then of course then there is alpha. Alpha is known as the coefficient of thermal expansion. Mostly it's like a linear. So now in today's experiment, what we are trying to determine is we're going to measure delta L, we're going to measure L0, and then we are going to measure the change in temperature of the metal, and using those information we are going to find alpha for the given material. So that means you will be using this alpha equals delta L divided by L0 multiplied by delta T to find the value of alpha. So for our experiment, what I'm going to do is I'm going to give you like three different materials. Then as you can see here, like the given materials are like aluminum, copper, and steel. So the original length L0 is given as the way you see it here. And then there's a micrometer setting. That means the material or like a dial, like if it was in a physical lab, we will be using some kind of a dial that is connected in some kind of a jacket or a tube, and then we let heat to pass through it so that the metal can get like some increment in temperature, and that dial is reading those values. Then you can find delta L. Delta L is going to be equal to the final micrometer setting minus the initial micrometer setting. So for instance, in this particular case, it's going to be 0.91 millimeter minus 0. Okay, then the initial temperature of the metal is given, and its final temperature is given as 100. Then you can find delta T, that means the change in temperature of the metal, by using 100 minus 24.1. Then that is your delta T, and then you will be using alpha. Okay, alpha measured. Alpha measured means you will be calculating alpha using this formula. Okay, using this formula. Then once you find that alpha, then you're going to compare that alpha with the theoretical alpha. As I mentioned, that alpha is the linear coefficient. Okay, the linear thermal coefficient of expansion, that's what we call it. Then you will be using the theoretical value and alpha measured value, and then you will find the percent difference between the two. Okay, so normally you may say like, where am I going to get the alpha value? Then the theoretical value is located in appendix A and table A3. Okay, then you will find the percent difference for the given three metals. The given three metals are given in the table. That's pretty much it. It's very easy and straightforward. You just simply use the equation and then find those formula. Find the alpha measured in the alpha accepted. That's pretty much it. Then thanks.